A charge q is enclosed by a Gaussian sphere of surface of radius r. If the radius is doubled, then the outward electric flux will be. So very tricky answer, tricky question. So therefore, we have flux is equal to q enclosed divided by epsilon naught. So now this Gaussian surface contains this charge q, and even when we make it double the radius, still it is going to contain the same charge q. So therefore the flux is going to be same, q enclosed divided by epsilon naught. So therefore it will remain the same, because the charge inside is same, whether you make the radius double or triple or even 1 lakh times. Thank you. The electric field at distance 3r/2 from the center of a charged conducting spherical shell of radius r is E. Okay, ये हो गया spherical shell है ना, this is a shell. The electric field at a distance r/2 from the center of the sphere. Actually speaking, inside the electric field is going to be 0 only. So it's going to be 0. Simple. A point charge q is placed at the center of a cube of side L. Okay, it's a cube again. The electric flux emerging from the cube is, so since the entire charge is located inside the cube, entire charge, so therefore the electric flux which is passing through the cube is going to be q enclosed divided by epsilon naught, which is actually q by epsilon naught. So therefore D is going to be the answer. Thank you. The given charges, the given figure gives electric lines of force due to two charges q1 and q2. What are the signs of the two charges? तो अब देखिए ध्यान से, बीच में there is no field line, so therefore the field is 0. तो जब field 0 है तो इसका मतलब कि दोनों जो है same sign का charge रहेगा, and all these fields lines are ending on q1 and q2, so therefore both of them have to be negative. So both are negative. Thank you. In a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. The magnitude of electric field in this region is amazing. If you see, electric potential is constant, so dV is equal to minus E dot dr. Since potential change, the change in potential is 0, so therefore electric field must be 0. So therefore D is the answer. Okay, because there is no change in potential, so that means electric field is constant in that volume. Thank you. Electric field is 0 in that volume. Sorry. 2 point charges A and B having charges plus q and minus q respectively are placed a certain distance apart. ठीक है, ये हो गया plus q, ये हो गया minus q. They are placed a certain distance apart. Let us say D. And force acting between them is F. तो F क्या हो गया? K into Q square divided by minus D square. ठीक है, ये हो गया force. 25% of the charge A is transferred to B. So this is A and this is B. तो ये 25% इसको transfer हो गया. तो ये कितना हो गया? ये हो गया 3q/4. ठीक है, और इधर भी 25% चला गया. So this also becomes minus 3q/4. So therefore the new force is equal to minus k into 9q square by 16 divided by d square. So therefore the new force becomes 9 by 16 into F original. ठीक है, तो इसलिए इसका आंसर हो जाएगा 9 by 16. Thank you. A charge q microcoulomb is placed at the center of cube. The flux coming out from each face will be, so because all the faces are going to be like symmetrical, for the charge, all the faces are going to be same. It's not, no face is going to be special. All the faces are equal for the charge. So therefore, if we consider phi as the flux due to one phase, so 6 phi is going to be the total flux, which is going to be q divided by epsilon naught. So therefore 6 phi is equal to q. It's q, the charge is q microcoulomb, so 10 to the power minus 6 divided by epsilon naught. So therefore, due to, from one phase is going to be q by 6 epsilon naught into 10 to the power minus 6. So therefore the answer is going to be A. Thank you. The acceleration of an electron due to mutual attraction between the electron and proton when they are 1.6 angstrom apart is, so it's going to be k q1 q2 divided by r square, that is the force, into 1 divided by mass of electron. So 9 into 10 to the power 9 into q1 is 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19. Distance is 10 to the power minus 10, so 1.6 into 10 to the power minus 10 into 1.6 into 10 to the power minus 10. Mass of electron is 9.1 into 10 to the power minus 31. Okay, everything is a SI unit, so 1.6 is gone, 9 and 9.1 is gone. So therefore this becomes 10 to the power, you have 31, so 20, 51 plus 9 minus 38. So 51 is 60 minus is 10 to the power 22 meter per second square. So the answer is going to be C. Thank you. So this is the dipole. Okay, so minus q and plus q. At r distance away, theta angle, it's going to be 2 kp cos theta by r cube, this direction, and in this direction is going to be kp sin theta by r cube. Now for equatorial plane, theta is going to be 90 degree, so therefore it's going to be kp by r cube in this direction. So kp by r cube, okay, so here there are two options, this is positive and this is negative. Okay, so we will take negative direction, because it is like, if it is like this, it's going to be in this direction. Okay, the dipole is in this direction, so it's going to be in this direction, therefore D option. Thank you. Two charged spherical conductors of radius r1 and r2 connected by wire. The ratio of surface charge density of the sphere is, okay, so there are two charged spheres which are connected by wire. So this is r1, this is r2, this is sigma 1 and this is sigma 2. The potential has to be same, so therefore we can write k into q, that is sigma 1 into 4 pi r1 whole square divided by r1 should be equal to k to sigma 2 into 4 pi r2 whole square divided by r2. K is gone, 4 pi is gone, this is gone, and this is also gone. So therefore a sigma 1 by sigma 2 becomes r2 divided by r1. So B is the answer. Okay, so basically the potential has to be same, and the potential's formula is kq by r. That's it. And how we calculated q? Q is sigma into surface area. Okay, so sigma into 4 pi r square, where sigma is the surface charge density. The angle between the electric lines of force and the equipotential surface is going to be 90 degree. Okay, how? We shall understand. So equipotential surface is a surface where the potential is going to be constant. Okay, so if we do dv is equal to minus e dot dr. Okay, this is the relationship. So if we move up, like on the surface, okay, like let us say, for a sphere, for a spherical surface, and the charge is kept at the center q. So what happens is that if we move across the surface, okay, dr, then e dot dr must be 0. So therefore, because of this dot going to be becoming 0, so therefore it should be cos 90 degrees 0. So therefore the angle should be 90 degree. Okay, so therefore b is the answer. Thank you. Two hollow conducting spheres of radius r1 and r2 have equal charges. The potential would be, they have equal charges. Okay, so what is the formula of the potential? The formula of the potential is kq divided by r. Since they are having equal charges, so therefore kq by r1 and kq by r2. Okay, so since r1 is much greater than r2, so therefore this is going to be the case. So potential will be less on the bigger sphere and more on the smaller sphere. Okay, so therefore a is going to be the answer. Thank you. 6 charges are fixed at the corners of hexagon as side B as shown in the figure. The work done in bringing a charge q naught to the center of the from infinity. Okay, so basically now what we have to do is we have to find out the energy which is there, due to this. So so all are actually at a distance L only. Okay, so the potential energy which is increased, if we see, okay, so we have to pair, so for this minus q there is plus q. Okay, so if becomes minus kq naught by L, now plus kq q naught by L. So this way you see both are going to cancel because it's equidistant from all. Okay, so the potential energy is going to be like cancelled from all. So therefore the net change in potential energy of the system, this becomes 0. Okay, so therefore a is the answer. Thank you. The ratio of coulombs electrostatic force to the gravitational force between electron and proton separated by some distance is this, is nearly, okay, we have to calculate it. So the ratio of coulombs, okay, so 9 into 10 to the power 9 into q1 into q2, that is 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 divided by r square, and then again divided by gm1 m2. So 6.6 into 10 to the power minus 11 into mass 9.1 into 10 to the power minus 31 into this mass is 1.6 into 10 to the power minus 27 divided by r square. It's gone. So this becomes 1.6 is gone, 9.1 and 9.9 is almost gone. So 1.6 divided by 6.6 into 10 to the power. Okay, now here we have to do some calculations. So it's minus 38 plus 9 is, it's minus 29 plus 11 plus 31 plus 27. So 31 plus 27 is 58, 58 plus 11 is 69, 69 plus 29 is 40. So it's of the order of 10 to the power 40. So therefore the answer is going to be C. Thank you. The variation of electrostatic potential with a radial distance r from the center of a positively charged metallic thin shell. Okay, so it's a thin shell. okay, of radius r is given by. So the potential, what happens is, in a thin shell, uh, see, like as we go for r greater than r, the potential is going to be simple, k into q divided by r. Okay, now for r is equal to r, it's going to be, potential is going to be k q divided by r. Now for r less than r, okay, inside a hollow spherical shell, the electric field is going to be zero, because like due to Gauss's law, uh, if you want we can prove also. Okay, so no, so this is the sphere, and this we are taking as the Gaussian surface. So in the Gaussian surface, integration E dot ds should be equal to q enclosed divided by epsilon naught. Now it is hollow, na? So therefore inside there is no charge, so therefore q enclosed is 0. So E ds is also 0, and E should be same at all the points due to symmetry, so therefore electric field is 0. So therefore at r less than r, electric field is 0, and since electric field is 0, so dv is equal to minus E dot dr, this also becomes 0. So therefore there is no change in potential from the surface, so therefore at all r less than r, potential is going to be kq by r only. So if we want to draw the graph is going to be like this. Okay, it's kq by r, and then it goes like this. This is r, this is small r, and this is kq divided by r. Thank you. 27 drops of same size are charged at 220 volt each. So if you see, 1, so we can tell that kq by r is equal to 220 volts. Okay, so now if you see, like the charge density, so it's k into 4 by 3 pi r cube into sigma by r. This is going to be 220 volts. So therefore k into 4 by 3 into pi into r square into sigma is 220 volts. Let us keep this in mind. Now when all of them together, they form a bigger drop. So therefore now the radius of the bigger drop, okay, so it's 27 into 4 by 3 pi r cube, this is the volume, and now it makes a bigger drop, 4 by 3 pi into r cube. So therefore if you see, r becomes 3 times small r. Okay, so therefore the charge is going to be k into 4 by 3 into pi, the potential, into r square sigma. So therefore this r is 3r, so therefore 9 times into 220 volts, which becomes 1980 volts. So therefore the answer is going to be C. Oh, I'm sorry, it's r square, right? Ah, yes. So r square, no? So n 9. That's good. So 1980. Thank you. A dipole is placed in an electric field as shown. In which direction will it move? So if you like observe here, okay, in which direction it's going to move? Electric field is in this direction, and dipole is in this direction. Okay, so you see, then u is equal to minus p dot e. Okay, Achha, this is actually not of so the electric field is sorry, the electric field is greater here and the electric field is less here, we can see due to the density of electric field lines. Okay, so therefore this plus q, the plus q is going to experience a force in this direction QE, which will be greater, and minus q will experience a force in this direction which will be again QE2. So since this is greater, so therefore this is going to move in the forward direction. Okay, that is in the right direction. Also u is equal to minus p dot e. Okay, so therefore we can see that the potential energy is also, minus p dot e, it's maximum, it is maximum. So therefore again it's going to move in the right direction only, because electric field will be less and therefore the potential energy will decrease, and any arrangement is stable only when the potential energy becomes less. Okay, so therefore the answer is going to be B. Thank you. 2-point charges minus q and plus q are placed in distance L. Okay, the magnitude of electric field intensity at a distance r greater than L. Okay, this varies as, so it will be 1 by r cube. Again let us see. So this is minus q, this is plus q. Electric field at a point is going to be 2 kp cos theta by r cube, and this direction is going to be kp sin theta by r cube. So therefore it is like dependent upon 1 by r cube. Okay, better we remember it. Polar molecules are the molecules. So polar molecule is having a delta negative charge and a delta positive charge. Okay, so they have zero dipole moment. No. They acquire a dipole moment only in the presence of electric field. No. They acquire only when, no. They have a permanent electric dipole. Yes, they have a permanent electric dipole. D is the answer. Thank you. An electric dipole is placed as shown in the figure. The electric potential at point P due to the dipole is, so for a dipole, minus q plus q, okay, at theta angle. Here the dipoles, the potential due to the dipole is going to be kp cos theta divided by r square. Okay, so now it's cos theta. Now here we are taking it on the axis, so therefore theta will become 0 degree. So therefore it becomes k into p. What is p? So it's q into 6 centimeter divided by the r square. Okay, now here very interestingly, if you see that we are having everything in terms of centimeter. Okay, so it's like so here actually we can calculate very straightforward. So it's going to be kq by r, simple. So kq by minus kq by 8 plus kq by 2. So it's going to be kq by 8, 4 minus 1, so it's going to be 3 by 8 kq. Okay, this formula is there, it's okay, but like the here we can, because r and l are okay, like the distance between the charges, and the point where we are calculating, both are quite comparable. So that's why we can directly use this formula, or we can use this formula if we use. So it's kq into 6 centimeter and cos theta is 1 divided by r square. that is 6. No, it's 5 into 5. And if you see, this formula is, it's like not working. Why it's not working? Because it's comparable. Okay, so we cannot use this formula. This formula is only used when uh, this is D, so D should be less than R. Okay, D is the distance between the two charges, R is the the distance of the point from the center of the dipole. So therefore we have to use this formula, as both are quite comparable. So therefore the answer is going to be B. Thank you. F integration of E dot ds is equal to 0 for over a surface, then the electric field inside the surface is necessarily uniform. No, need not be. Need not be that the electric field inside the surface is uniform, because we can see this for an example. Like for example, this is plus q and this is minus q, and we take this. Okay, so because the q enclosed is 0 algebraically, so therefore integration of E dot ds is going to be 0, but the electric field inside is not uniform. Okay, so therefore A option is wrong. Okay, the number of flux lines entering the surface must be equal to the number of flux lines leaving it. Yes, that's true. That's true. Because like E dot ds is equal to 0. So if there is like E dot ds is positive at a place, then E dot ds has to be negative at another place, because overall it's going to be 0. Okay, so yes, like we can see an example, we can see this is a like we are taking a cube, something like this. So okay, we can see that here we don't have any charge enclosed, so therefore the q enclosed is equal to 0. See, what is the Gauss's law? Gauss's law is integration of E dot ds is equal to q enclosed divided by epsilon naught. So in this case q enclosed is 0, so therefore integration E ds must be 0 over the surface. So now if you see the rays or the line, the flux lines which are coming inside, they have to go outside. Okay, because on one side if it is positive, on the other side it should be negative. Okay, because area vector is going to be like, area vector is like this, so therefore here if you see both of them, they are at 180 degree. Okay, so both of them, they are at negative, so here it is like, here it is positive. Okay, okay, so B is going to be correct. Okay, B is going to be correct, A is going to be false. The magnitude of electric field on the surface is constant. No, again this also did not be, because we see this in example. Again plus q is there and minus q is there, and this is the Gaussian surface. So these are the field lines. Okay, if we see that okay, so these are the field lines. These are the field lines happening like this. So we can see here that electric field need not be uniform over the surface. Okay, if it is like quite nearer to the edge, so here the electric field will be more, here the electric field will be less, and like that. So therefore C is also not the correct option. All the charges must necessarily be inside the surface. No, not required. Charge can be outside the surface also. For example, we have this plus q charge is there. Okay, so this is how the electric field is there, and if we keep this as the Gaussian surface, so therefore the charge is not inside the surface, so therefore it need not necessarily be inside this surface. Okay, that is wrong, so only B option is correct. Thank you. A hollow insulated conduction sphere, so this is a conduction sphere and this is insulated, and okay, and it is hollow sphere. Okay, what will be the electric field? Center of the sphere's radius is 2 meters. So irrespective of the radius, the electric field inside the hollow sphere is going to be 0 always. Okay, we can prove this also. So this is a hollow sphere. Now it is having like uniformly distributed charge throughout. Now take a Gaussian surface like this. Okay, so for this Gaussian surface, now we calculate phi. Okay, so integration of E dot A, this is going to be Q enclosed divided by epsilon naught. Since Q enclosed is going to be 0 only, and electric field is going to be radial because it's going to be symmetrical, because the charge distribution is symmetrical, so therefore electric field into area is going to be 0. So the electric field becomes 0 inside a hollow spherical shell, so therefore the answer is going to be C, that is 0. Thank you. A hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere at a distance r from the center is, so since it is a hollow metal sphere, okay, so this is hollow, so that means the entire charge is actually on the surface of the sphere and no charge is inside. So since no charge is inside, so therefore this is what the graph of electric field going to look like. So no charge is there inside, so therefore the inside electric field is going to be 0. Okay, till radius r, and then the electric field abruptly rises to kq by r square, and then from here the electric field goes like this, which is kq by r square. So therefore now we can see here, so it is 0 as r increases for r less than r, that is true, and decreases as r increases for r greater than, that's true. So C is going to be the answer. Okay, for A and B, no, till r less than r it's 0 only, and here why it's wrong, because it doesn't increase as r increases, it's going to decrease. Thank you. Two parallel infinite line charges, so this is one line charge and this is second line charge. Okay, with linear charge densities plus lambda, this is plus lambda coulomb per meter और ये हो गया minus lambda coulomb per meter, are placed at a distance of 2r in free space. Okay, 2r in free space, इन दोनों के बीच में जो है 2r. Okay, what is the electric field midway between the two line charges? यहाँ पर electric field क्या है? So better is that we learn this formula. ठीक है, एक चीज़ देखिए ध्यान से, ये पॉजिटिव चार्ज है ना, तो इसके कारण इस डायरेक्शन में होगा, ये नेगेटिव चार्ज है तो इसके कारण भी इस डायरेक्शन में ही होगा, तो ज़ीरो नहीं होने वाला. ठीक है, एंड बेटर इज दैट वी लर्न द फॉर्मूला, एंड द फॉर्मूला इज, okay, the formula of the electric field is going to be yes, going to be lambda by 2 pi epsilon naught into r, okay, into 2. ठीक है, तो ये ख़त्म, ये ख़त्म, lambda by pi epsilon naught r. Okay, so D is going to be the answer. ओके अब ये कैसे आता है फॉर्मूला, है ना, जो कि मैंने डायरेक्टली यूज कर लिया, वो हम लोग देखते हैं. ठीक है, सो दिस इज द इनफाइनाइट line charge. We construct a Gaussian surface around it like this. Okay, and this is R. Okay, so now है ना, इसका हाइट जो है h रख लिया हम लोगों ने. Since it's infinite, so therefore the electric field is actually going to be radially outwards only, क्योंकि जो है it has to be symmetrical. Okay, it cannot be like this or like this. No, it has to be symmetrical. So therefore, since the electric field is like this, so therefore we can write very clearly that the electric flux, that is E dot dA, that is the area. So area क्या हो जाएगा, 2 pi r into h should be equal to q enclosed lambda into h divided by epsilon naught. So this goes, so therefore electric field becomes lambda by 2 pi epsilon naught r. This is the electric field due to an infinite wire. ओके, तो इसके कारण जो है यहाँ पे है लेमडा बाई 2 पाई एप्सिलॉन नॉट आर, और इसके कारण भी इधर ही है. सो देयरफॉर बोथ add to each other and therefore it is lambda by pi epsilon naught r. Thank you. A charge q is situated at the corner of a cube. Okay, so it is there situated at the corner of the cube here. So now to completely enclose this charge, we will require 8 cubes. Okay, so we will require 8 cubes. So therefore the flux through one cube is going to be q divided by 8 epsilon naught. Okay, and that flux is going to pass through the 6 faces of this cube. So therefore the electric flux passed through all the 6 faces of the cube is going to be q by 8 epsilon naught. Thank you. A charge q is located at the center of a cube. Okay, it is there at the center of the cube. Fine. Now what is they are telling us, the electric flux through any face is. So if you see, then for all the faces, it's going to be, this charge is going to be like symmetrical for all the faces. So how many faces are there? So there are total number of 6 faces. Okay, 1 2 3 4 5 and 6. So 6 faces are there total. So for since for all the 6 faces it's symmetrical, so if we consider for one phase, we consider the electric flux as phi. Okay, so therefore it's going to be 6 phi is going to be equal to q by epsilon naught. So therefore phi is going to be equal to q by 6 epsilon naught. Okay, so now we can see here that it's going to be b. Okay, because 4 pi gets cancelled, so it's going to be by q by 6 pi. Thank you. A hollow cylinder has a charge q coulomb within it if phi is the electric flux in units of voltmeter associated with the curved surface B. Okay, so electric flux through B, this surface is going to be phi. Okay, so now if you see the total electric flux, okay, so we consider this entire to be a Gaussian surface, so therefore phi total should be equal to q enclosed divided by epsilon naught. Now q enclosed is q itself, so q by epsilon naught. Now this phi total includes flux due to which is passing through C plus flux which is passing through B plus flux which is passing through A. Now A and C are going to be equal because of symmetry. Should be equal to C, due to symmetry. Okay, because whatever the flux lines are going to pass, okay, so it's going to be symmetrical through A and C. So therefore I can write here that Q by epsilon naught is equal to 2 into phi, like flux due to A, plus, now flux due to B is given here as phi, so therefore flux to A is going to be Q by epsilon naught minus phi into 1 by 2. So therefore D is going to be the answer. Thank you. What is the flux through a cube of side A? Okay, so we have this. Okay, if a point charge of Q is at one of its corner, okay, so this is the cube. Okay, this is the cube. So now we have at one of the corners we have a point charge. Okay, so if you see, to completely encircle, or to completely keep the charge inside, there has to be more cubes attached. Okay, ठीक है, पूरा उसको लाइक घेर करके बंद करके करने के लिए हम लोग को कितने क्यूब्स लगेंगे? दिस इज वन क्यूब हियर, 3, 4, and then that side also 5, 6, below 7 and 8. ठीक है, otherwise some part will be out. So therefore this charge Q is going to be divided into 8 parts. So only 1/8 part is inside this cube. So now the flux is going to be equal to Q enclosed divided by epsilon naught. So since Q by 8 is enclosed inside, so therefore Q by 8 epsilon naught is going to be the answer. Okay, once again I will I'll show you that like you see, if this charge is there, okay, and it is located on one of the vertices. Okay, we are seeing from this side, when we are seeing, this is what we are going to see. So now if you see, this is look, we require 4. Okay, we require 4 cubes, and still some part will be projected outside. So we require 8 cubes for this charge to get completely enclosed inside. Okay, so therefore since 8 cubes are required, so therefore 1 cube is having 1/8 of the charge. Okay, and if we see from this charge point of view, so okay, so this is the charge in one of the cubes. Okay, like that. So that's how it is. Thank you. Electric field at center O of a semicircle of radius A having linear charge density lambda is given by. Okay, तो जो है ठीक है, so at an angle theta, let us take d theta. ठीक है, तो d theta ले लिए, तो d theta means, so this is going to be a d theta. Okay, this is the arc length. Since linear charge density is lambda, so therefore the charge is going to be lambda into a d theta. Now due to this, the electric field is going to be in this direction. How much? It's going to be kq by r square. So k into the charge a d theta divided by a square. Okay, Now symmetrically it's going to be from here also in this direction. So now, so this is theta, this is theta, so the sine theta component is going to cancel out, so therefore only cos theta is remaining. So cos theta, now we have to integrate it. Okay, theta goes from minus pi by 2 to pi by 2, so this becomes k lambda by a into cos theta is the differential integration is minus, no, it's going to be sine theta from minus pi by 2 to pi by 2, so it's going to be k lambda by a into 2, so 1 by 4 pi epsilon naught into lambda by a into 2, this is going to be lambda by 2 pi a epsilon naught. So C is going to be the answer. And just again I will show you how we integrated. Okay, so we took at an angle theta, we took an angle d theta, so therefore this arc became, now the radius is a, so this arc became a into d theta. Now since it is having lambda charge per unit meter, so if I just multiply it by lambda, we get the small charge which is located here. Now this small charge is going to produce an electric field in this direction. Okay, so how much? K into dq by a square, and due to symmetry if we see here also there will be, you know, similar charge which is going to produce in this direction. Okay, so this is theta, this is theta, these two components are going to cancel, only cos theta remains, so therefore we have put cos theta, and that's what you know, now we replace the dq, it's going to be a d theta into lambda, and that's exactly what we have done here. So k dq by a square into cos theta, and the integration will be happening from minus pi by 2 to pi by 2. That's how we did it. Thank you. A thin conducting ring of radius r is given a charge plus q. The electric field at the center O of the ring due to the charge on the part AKB of the ring is E. The electric field at the charge at the center due to the charge ACDB, okay, is okay. So like if you see, because the charge is distributed uniformly, so therefore like the electric field at the center is going to be 0, because for this charge, if the due to this charge the electric field is in this direction, due to the charge symmetrically opposite to it, the electric field is going to be in this direction, so all are going to cancel each other, so therefore the electric field at the center is going to be 0 due to symmetry. Now important thing is, now due to AKB, okay, the electric field is, the electric field at the center A due to of the ring is E, okay, so E is going to be in this direction. Now 100% due to all these three combined, you know, A, C, D, B, it's going to be opposite of that of AKB, because for together it's going to be 0. Okay, so like we can write here that net electric field is going to be 0. So net electric field is going to be electric field due to AKB plus electric field due to ACDB. Both of them combinedly are going to make it 0. So now electric field due to ACDB is going to be minus of electric field due to AKB. So that is what, okay. So the electric field at the center of O of the ring due to the charge on AKB is E. So this is going to be E, okay. So since this is E, so this has to be minus E. So the direction has to be opposite, okay. So due to this entire ACDB, it's going to be this one. Okay, the magnitude is E and it should be along OK. So this is D. D is going to be the answer. A spherical conductor of radius 10 centimeter has a charge distributed uniformly. So this is a spherical conductor. Okay, the radius of the spherical conductor R is 10 centimeter and it has a charge. Let us say charge is Q. So Q is 3.2 into 10 to the power minus 7 coulomb. It's distributed. What is the magnitude of the electric field at a point 15 centimeter from the center of the sphere? Okay, 15 centimeters. It's already 10, so 5 centimeter from here. Okay, because it is distributed uniformly, so therefore we can see it as a case of a hollow sphere. Okay, or even a solid sphere also, it doesn't matter, because it's because the point where we have to calculate the electric field is outside the sphere. So therefore it will simply become KQ divided by R square, and R is the distance from the center. So therefore K is 9 into 10 to the power 9 Newton meter square per coulomb square into Q. Q is 3.2 into 10 to the power minus 7 coulomb divided by R square. R was 15 centimeter. So 125 into 10 to the power minus 4 meter square. So meter square is gone. Coulomb. So it's okay, it's like 27.2 divided by 125 into it's not 27, it's 20, 28.8 by 125 radius 10 centimeter. Okay, 15 cent is 225, actually it's not 125, so it's 225 into 10 to the power minus 3, so that is 10 to the power 6. Okay, so this becomes 1.28 into 10 to the power 5 Newton per coulomb. Okay, so B is going to be the answer. Thank you. A dipole of dipole moment P is placed in a uniform electric field and the torque acting on it is given by. So this is a simple formula. Torque is equal to P cross E. We will derive this formula. Okay, so this is minus Q and this is plus Q. Okay, so and let us say this is the direction of the field. Okay, so therefore the force is going to be QE in this direction and here also in this direction. Okay, the angle between them is going to be theta. Okay, so let this be A and let this be also be A. So therefore we can see that the net force is going to be 0, because net force is plus QE and minus Q, both are in opposite direction, but there is going to be a torque. So this QE is this is going to produce a torque in which let us see. So this is QE cos theta and this is QE sin theta, because this is the theta. So this is going to produce a torque in clockwise direction, and this is also going to produce a torque in the clockwise direction, which is again QE sin theta, the component of the force. So therefore the component of this force which is going to produce a torque is going to be so the torque is R cross F. So therefore QE sin theta into A. Okay, and this will not produce any torque because it is acting along the along R vector. So therefore QE sin theta into A into 2. So this becomes 2QA into E into sin theta. 2QA is P, so therefore it's P cross E. So therefore the torque becomes P cross E. Thank you. An electric dipole is placed at an angle 30 degree with an electric field intensity this. it experiences a torque equal to the charge on the dipole. Okay, so the torque on a dipole is given by P cross E. Now here cross is the cross product, so therefore magnitude of P into magnitude of E into sine theta. This is the torque. Okay, so now let us put back, put the values. So 4 Newton meter is equal to P. P is Q into the distance, dipole length. So Q into 2 centimeter. Electric field is 2 into 10 to the power 5 Newton per coulomb. An angle is 30 degrees, so sine 30 is 1 by 2. So therefore 2 is gone. This 2, it goes with 2. Newton is gone with Newton. So therefore Q becomes, and now this is meter and centimeter, so we make it here 100. Okay, so 2 into 10 to the power minus 3 coulomb. Okay, so this is 2 millicoulomb. Therefore 2 millicoulomb is going to be the answer. Thank you. There are 3 point charges which are placed at, okay, so let us make the axis. This is the axis. Okay, 3 point charges, Q minus 2Q and Q. So Q is at x equals 0, y equals a. Okay, so यहाँ पे Q है. Okay, then x equals 0, y equals 0, z is equals 0, it's minus 2Q here, and a is plus Q is in the direction x equals a. Okay, so this is plus Q here. So now what we have to find the magnitude and direction of the electric dipole moment vector of this charge assembly. So what we can do is we can break this minus 2Q into 2 charges, which is minus Q and minus Q. So now we can clearly see that for this combination, this is the dipole moment vector, and this is the electric dipole moment vector for this combination of charge. So now here the P is going to be Q into the distance between both of them, so it's going to be Q into A. This is also Q into A. Okay, this is I cap, this is J cap. So therefore it's going to be in this direction. The vector sum is root 2 QA. Okay, and it is like 45 degrees, so it is along the line joining 0 0 and A comma A. So it is root 2 K along the line joining points x equals 0, y equals 0, z, and x equals A, y equals A. That's correct. Okay, it is not K, it is not along x direction, it is not along. Okay, so A is the answer. Thank you. A point Q lies on the perpendicular bisector of an electric dipole. So this is the electric dipole. This is minus Q, this is plus Q. Okay, of an electric dipole of dipole moment P, if the distance of Q from the dipole is R, then the electric field at Q is proportional to, and it is lying on the perpendicular bisector. So we will make a general formula. This is a general formula, and this is theta. Okay, so the electric field is going to be in this direction and in this direction. Okay, so in this direction it's going to be 2 kp cos theta by r cube, and in this direction it's going to be kp sin theta divided by r cube. Now since it is at perpendicular bisector, so therefore theta becomes 90 degree. So here the electric field is going to be in this direction, which is kp by r cube. This is minus q and this is plus q. So therefore then the electric field is proportional to p and r to the power minus c. So therefore D is going to be the answer. Thank you. A square surface of side L meters is in the plane of the paper. Uniform electric field also in the plane of the paper is limited only to the lower half of the square surface. See figure. The electric flux in SI units associated with the surfaces. Okay, so like for any area, the electric for the area vector is going to be, okay, so in this case it's going to be, it is like perpendicular to the plane of the figure. So now here we can see that electric field vector is in this direction and area vector is in this direction. Okay, so electric field is in I direction and the area vector is in K direction. So therefore, since flux is going to be E dot A, so the angle between them is going to be 90 degree. So therefore cos 90 is going to be 0. So therefore we have 0 here. The electric flux is 0. Thank you. The square surface of side L meter in the plane of the paper is placed in a uniform electric field E, acting along the same plane at an angle theta with the horizontal side of the square as shown in the figure. The electric flux linked to the surface in units of voltmeter is. So what is flux? Phi is equal to E dot A. Okay. Now electric field, we are able to see the electric field is in this direction. What is the direction of A? That's important. ठीक है, तो कोई सा भी एरिया है ना, whatever area we take, okay, so like this is the area which we are taking here, the area vector is perpendicular to the plane of the area. Okay, so this is the area of the, like this is the square and the plane of the square is XY plane. Now perpendicular to this plane is going to be the area vector of this square. Okay, so now this is going to be in Z, it's like coming out of the plane of the paper and it may even go inside of the plane of the paper, but in both the cases it is making an angle of 90 degree with the electric field. Okay, so if you see, now this is Z direction and because this is an XY plane only, so therefore it's going to be 0. Okay, so here again, like I reiterate, what is the direction of the area vector? So the area vector's direction is perpendicular to the figure or perpendicular to the shape of the area. Okay, that's it. So therefore the electric flux, so now because it is perpendicular and E dot A, this is a dot product, so therefore it's magnitude of A, magnitude of E, magnitude of A into cos theta. Now what is the theta between them? If it is 90 degree, so cos 90 degree is 0. Okay, so therefore the phi becomes 0. Thank you. A particle of mass m and charge q is placed at rest in a uniform electric field E and then released. ठीक है, यूनिफॉर्म इलेक्ट्रिक फील्ड है और चार्ज इस पे क्या है, Q, and this is mass इसका है m. Okay, after moving a distance y. So now if you see, the force on this particle is going to be Q into E. So therefore acceleration becomes QE by m. So now we can find the final velocity. V square equals U square plus 2 into A into S. Okay, initial velocity was 0, so therefore V square is equal to 2 into A QE by m, and how much distance it has moved? Y. So 2E, this is the, yes. So now the kinetic energy is half m V square, so this is going to be half into m into 2 QE m into y. Gone. This is QEY. Okay, this is based upon the basic general equations of motion. We can also solve it by a different method. क्या है method? देखिए ध्यान से. The force is QE and the force acts on the particle for y distance. So therefore the work done by the force is QE into y, which is going to be change in the kinetic energy. Okay, so in both the cases we see the answer is going to be the same, that is QEY. Thank you. An electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. Okay, तो इलेक्ट्रॉन जो है यहाँ पे था, है ना, द इलेक्ट्रॉन नाउ इट फॉल्स फ्रॉम रेस्ट थ्रू अ वर्टिकल डिस्टेंस h. कितना दूर गिरा ये, h गिरा ये, ठीक है. So electron has come here in a uniform and vertically upward direction electric field. So this is the electric field. Okay, the direction of electric field is now reversed, keeping its magnitude the same. Okay, a proton is allowed to fall from rest on it through the same vertical distance h. The time of fall of the electron in comparison to the time of fall of the proton is. Okay, तो देखिए ध्यान से, ठीक है. So let us first see the case of electron. Electron is there. Okay, electric field ऊपर है, तो इसीलिए इसके ऊपर फोर्स ऐसा लगेगा E इंटू ई प्लस इस मास ऑफ इलेक्ट्रॉन इंटू जी, ये है फोर्स लग रहा है इसके ऊपर, नेट फोर्स. सो देयरफॉर एक्सेलरेशन विल बी दिस डिवाइडेड बाय मास ऑफ इलेक्ट्रॉन विच इज इक्वल टू जी प्लस ई इंटू ई डिवाइडेड बाय मास ऑफ इलेक्ट्रॉन. Now when proton is there, proton also experiences, because proton also has the same magnitude of charge, E into electric field plus mass of proton into gravity. This is the force on proton. So therefore acceleration of the proton will be EE plus mpg divided by mass of proton. So this is G plus EE divided by mass of proton. Because mass of proton is higher, so therefore acceleration of electron is going to be greater than acceleration of proton. Okay, so therefore the time of fall of the proton is going to be lesser. Time of the electron, time of fall of the electron in comparison to time of fall of the proton is going to be lesser. So therefore यहाँ पे अगर देखेंगे तो there is only one option which is smaller, which is A. So therefore, है ना. अच्छा, लेस क्यों होगा ये भी देख लेते हैं. Now this is quite simple. Half A T square is equal to H. So T becomes 2H by A. So this is A, sorry. ठीक है, तो जिसका एक्सेलरेशन ज़्यादा होगा, टाइम ऑफ फॉल कम होगा. A toy car with charge Q, so this is a toy car, this is having a charge Q, moves on a frictionless horizontal surface. It's a frictionless horizontal surface under the influence of a uniform electric field E. This is the electric field E. Due to the force QE, तो अब इस पे फोर्स लगा Q into E. Okay, its velocity increases from 0 to 6 meter per second in 1 second duration. Okay, so if you see, the acceleration is going to be constant, which is QE by m, mass of the toy car. So now V is equal to U plus AT. Initial velocity was 0, so like 6 is equal to 0 plus A, which is QE by m into T, which is 1. So therefore QE by m is going to be 6. Okay, at that instant the direction of the field is reversed. Okay, अब लेकिन क्या हो गया, now it is moving with 6 meter per second, but now the electric field direction is reversed. The car continues to move for 2 or more seconds under the influence of this field. हाँ, क्योंकि अब देखिए, पहले तो ये इधर जाएगा, यहाँ पे इसका स्पीड लाइक इट विल फॉल टू 0, एंड बिकॉज द डी एक्सेलरेशन इज ऑल्सो दैट मच, तो 1 सेकेंड के बाद इट्स गोइंग टू बी 0. ओके, सो इफ वी सी इट्स वेलोसिटी टाइम ग्राफ, इट्स गोइंग टू बी समथिंग लाइक दिस. द स्पीड इंक्रीज्ड and then the speed decreased with the same magnitude of deceleration. So this was 0, this is 1, and this is 2 seconds. But now it is said that the car continues to move for 2 or more seconds under the influence of this field. ठीक है, तो ये फिर से नीचे गया है ना 3 सेकेंड, और ये और इधर जाएगा ये, like that. Okay, the average velocity and the average speed of the toy car between 0 to 3 seconds. Okay, for 2 more seconds अंदर. Okay, तो यहाँ तक है ये actually. Okay, so this is the VT graph. The average velocity and the average speed of the toy car between 0 to 3 seconds is. Okay, तो VT graph को यहाँ पे थोड़ा अच्छे से और बना लेते हैं. ऐसे गया, ऐसे 0, and now this is this. This is 1, this is 2, and this is 3 second. This is 0, and this is 6. So now we have to find the average velocity. Now what is the formula for average velocity? Velocity average is equal to total displacement divided by total time. तो total displacement क्या हुआ? तो इधर देखिए, half into base 2 into 6 positive, इधर negative है, half into base 1 into height 6, ठीक है, negative. तो ये कितना हो गया 6, ये हो गया -3. So this is 3 divided by 3, this is 1 meter per second. Okay, now speed average, speed का average is total distance divided by total time. तो कितना हुआ 6 plus 3, 9 meters divided by 3, this is 3 meter per second. क्योंकि डिस्टेंस में आपको दोनों तरफ पॉजिटिव ही लेना पड़ेगा. So therefore the answer is going to be 1,3, that is B. Thank you. Point charges plus 4q. Okay, so this is x equal to 0, this is x equals a, and this is x equals 2a. So plus 4q is kept here, minus q is kept here, and plus 4q is kept here. Then okay, now we have to find out, okay, what type of equilibrium is there. Okay, fine. So so if we can see, all the charges are going to be actually in equilibrium. ठीक है, कैसे? तो this is going to experience a repulsion in this direction by 4q, so it becomes k into 16q square divided by a square, sorry, 2a whole square, so this is 4a square, so this is k into 4q square by a square. This is going to experience a force in this direction due to this small charge, which is k into 4q into q divided by a square, which is again k into 4q square divided by a square. So this is in equilibrium. Okay, that's there. Now let us go step one by one. So only minus q is in stable equilibrium. So let us see minus q. Minus q is having attraction here also and attraction here also. However, अगर इसको थोड़ा सा हम लोग इस डायरेक्शन में लेके जाते हैं, है ना, थोड़ा सा इसको हम लोग डिस्प्लेस करते हैं इस डायरेक्शन में, सो यू सी व्हाट इज गोइंग टू हैपन, दिस अट्रैक्शन फोर्स विल इंक्रीज एंड दिस अट्रैक्शन फोर्स विल डिक्रीज, और ये ज़्यादा ही इंक्रीज करता रहेगा क्योंकि ये इधर जाता रहेगा. क्यों इंक्रीज करेगा? क्योंकि इट इज़ नाउ गोइंग टू बी k इंटू 4q इंटू q डिवाइडेड बाय दिस डिस्टेंस विच इज x स्क्वायर. And now x is less, so therefore this force is going to be more. So only minus q is in stable equilibrium. No, stable तो है ही नहीं है. It is not in stable equilibrium. Equilibrium is there, but it's not stable. It's unstable equilibrium. Okay. B, all the charges are in stable equilibrium. That is also wrong. Okay. None of the charges in equilibrium. ये भी गलत है. सब चार्ज तो equilibrium में है ही. ये भी equilibrium में, ये भी है, और ये भी इट्स द सेम है ना, ये दोनों सेम ही है. ठीक है. सो देयरफॉर ओनली सी इज गोइंग टू बी द ऑप्शन दैट ऑल ऑफ द चार्जेस आर इन अनस्टेबल इक्विलिब्रियम. ठीक है. तो इसका तो अनस्टेबल हम लोगों ने प्रूव कर दिया. दिस इज इन अनस्टेबल इक्विलिब्रियम. Why it is in unstable equilibrium? ठीक है, क्योंकि ये जो छोटा चार्ज है अभी तो इसके ऊपर दोनों फोर्स सेम लग रहा है, लेकिन इसको अगर थोड़ा सा स्लाइटली डिस्प्लेस किया इधर, तो दिस अट्रैक्शन फोर्स है ना, अगर इसको हम लोग 1 लिखें, इसको 2 लिखें, इसको 3 लिखें, सो फोर्स ड्यू टू 3 is going to be greater than force due to 1, so therefore it will be pulled towards 3. Now if we see here, what's going to happen, that this 4q charge, if we like move it little, displace it towards the, let us say, right side, so what's going to happen when we displace it towards right side, this attraction force is going to increase this, and of course this repulsion force is also going to increase, but it's not going to increase that much. Okay, so therefore this will be pulled towards minus q. Okay, so all the charges are in unstable equilibrium, that's there, so C option will be the answer. A charge small q is placed at the center of the line joining two equal charges q. तो ये हो गया q, ये हो गया q, और and this is the line joining both of them, और उसके बीच में there is a small q. The system of the three charges will be in equilibrium if q is equal to, small q is equal to, okay. अभी हमको we have to make it keep it in equilibrium. So if you see, like this is d by 2 and this is d by 2. So let us focus on this capital Q. So now it is going to suffer a repulsion from capital Q. So therefore the force is going to be K into capital Q whole square divided by d square. This Q must attract, so therefore this Q has to be negative. So in this direction the force becomes K into Q into small q divided by d by 2 whole square. Both have to be equal, so therefore equating, so K is gone, Q is gone, d square is gone by d square. So this becomes Q 1 by 2 whole square, so therefore 4q is equal to q, so therefore small q becomes q by 4 in magnitude. Okay, the sign should be negative, so therefore q should be minus q by 4, then only there will be equilibrium. So therefore A is the answer. Thank you. When air is replaced by a dielectric medium of constant K, the maximum force of attraction between two charges separated by a distance. ठीक है, तो पहले कितना था फोर्स, पहले था k q स्क्वायर बाय डी स्क्वायर. ओके, अभी डाइलेक्ट्रिक डाल दिया तो क्या हो जाएगा, f हो जाएगा लाइक दिस इज 1 बाय 4 पाई एप्सिलॉन नॉट इनटू एप्सिलॉन r इनटू q स्क्वायर बाय डी स्क्वायर. तो सिंपल है, व्हेनेवर डाइलेक्ट्रिक जब भी हम लोग यूज करते हैं, whenever the dielectric is used, anywhere where epsilon naught was there, now you replace it by epsilon naught into epsilon r. This is the permittivity of the medium, this is the permittivity of vacuum or air. Okay, so whenever dielectric is there, do this. So we also have done this only. So now this was f, now make it as f dash. Okay, so we can see f dash is equal to f divided by epsilon r, which is k, f by k. So therefore it decreases by k times. So that's C option. Two positive ions each carrying charge q are separated by distance d. ठीक है, each carrying a charge q, दोनों आपके पास चार्ज क्या है, q है, separated by a distance d. If f is the force of repulsion between the ions, तो f क्या हो जाएगा, k q स्क्वायर by d स्क्वायर. ओके, The number of electrons missing from each ion will be, okay, E being the charge on an electron, ठीक है. तो number of electrons missing from each ion, तो this Q is going to be N into E, ठीक है. मानी कि अगर एक इलेक्ट्रॉन में से है तो 1.6 इंटू 10 पावर माइनस 19 कूलम आ जाता है चार्ज. तो लाइक n electrons are missing, so Ne is going to be the charge. So therefore we can very easily write F is equal to 1 by 4 pi epsilon naught into n square E square by D square. Now we have to find n. So n is going to be F D square into 4 pi epsilon naught divided by E square. Okay, इसका पूरे का रूट. So FD square by E square. So this is C number. Thank you. Two identical charged spheres suspended from a common point by two massless strings of length L are initiated at a distance t. तो कुछ ऐसा है कंडीशन, ठीक है. एक ही पॉइंट से ये दोनों जो है हैंग कर रहा है, ठीक है. एंड द सेपरेशन बिटवीन देम इज एक्चुअली d. D है सेपरेशन इन दोनों में. नाउ कीप इन माइंड d इज़ वेरी लेस देन L, ठीक है. ये हो गया L, ये हो गया L. तो अगर अब फ्री बॉडी डायग्राम हम लोग बनाएंगे तो कुछ ऐसा बनेगा. mg, इधर हो गया टेंशन T, और इन दोनों के बीच में देयर इज इलेक्ट्रोस्टैटिक फोर्स, सो देयरफॉर K Q स्क्वायर डिवाइडेड बाय D स्क्वायर, ठीक है. तो अभी एक का फ्री बॉडी डायग्राम बनाइए, है ना. ये बना हुआ है एक का फ्री बॉडी डायग्राम. नाउ ये थीटा है तो ध्यान से देखिए ये भी थीटा हो गया. सो देयरफॉर वी कैन राइट T cos theta is equal to mg, this is first, and T sin theta is equal to K Q square by D square. लेकिन because you know there is a leak, there is a charge leakage and they are coming together, so therefore I am writing here x, where x is the distance, ठीक है. I am replacing d by x. Second, so therefore what happens is tan theta हो गया K Q square by x square into mg. Now what is tan theta? tan theta अगर ध्यान से देखिए it is x by 2 divided by L. तो x by 2L is equal to KQ square by x square into mg. So that means x cube is equal to Q square into some constant C. तो C क्या हो जाएगा? C है ना, लाइक बेसिकली क्या हो जाता है, एक्स क्यूब इज इक्वल टू के इंटू 2L बाय एम जी इंटू क्यू स्क्वायर, ठीक है. सारा कुछ एक तरह लेके आ गया. तो ये जो है दिस इज C, दैट्स व्हाट वी हैव रिटन हियर. Now what is being said here is that the charge is leaking at a constant rate, ठीक है. तो चार्ज लीकिंग क्या हो गया, डी क्यू बाई डी टी. जैसे कि फॉर एग्जांपल ये था पहले क्यू चार्ज इसमें, अब ये चार्ज हो गया इसके अंदर डी टी टाइम के बाद क्यू माइनस डी क्यू, ठीक है. सो देयरफॉर द लीकेज इज एट ए कांस्टेंट रेट, सो देयरफॉर डी क्यू बाई डी टी ना, डी टी टाइम के बाद क्या हो जाएगा, क्यू माइनस डी क्यू. सो डी क्यू बाई डी टी इज कॉन्स्टेंट. अच्छा, तो जब डी क्यू बाई डी टी कॉन्स्टेंट है तो इसमें अब हम लोग को थोड़ा सा कुछ जो है थोड़ा दिमाग लगाना पड़ेगा. क्या है भैया, तो क्यू स्क्वायर सी वॉज इक्वल टू एक्स क्यूब. सो देयरफॉर आई कैन राइट क्यू इंटू रूट सी इज इक्वल टू एक्स टू द पावर 3/2. Now differentiate on both the sides. So this is going to be dq by dt is equal to root c, sorry, into root c is constant, is equal to 3/2 x half dx by dt. Now this is also another constant c1, so therefore we can very clearly tell that dx by dt is proportional to x to the power minus हाफ. ठीक है, क्योंकि अगर ये वाला अगर हम लोग रिलेशनशिप लिखें तो ऐसा हो जाएगा dx बाई डी टी इज इक्वल टू c1 रूट सी इंटू 2/3 इंटू 1/x टू द पावर हाफ. ये सब कुछ तो भैया कांस्टेंट है ना. So therefore dx by dt, which is v, is proportional to x to the power minus half. It's quite a good question and like integration involve karta hai. Fine. So therefore v is proportional to x to the power minus half. Thank you. Two pith balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is r. Okay, now the strings are rigidly clamped at half the height. The equilibrium separation between the balls now becomes, okay, तो यहाँ पे हम लोग को दिख रहा है पहले वाले में. ठीक है, पहले वाले का एबीडी बना लेते हैं, फर्स्ट वन का. सो दिस इज टी, दिस इज एम जी एंड दिस इज के q square divided by r square. So we can write here very clearly ना, और ये है थीटा. ठीक है, थीटा 1 लिख लेते हैं. सो t cos थीटा 1 इज इक्वल टू एम जी, t sin थीटा 1 इज इक्वल टू के क्यू स्क्वायर बाय आर स्क्वायर. सो देयरफॉर tan थीटा 1 इज इक्वल टू के क्यू स्क्वायर बाय आर स्क्वायर एम जी. ये हो गया पहला. अच्छा, अब ये tan थीटा 1 है क्या? दिस tan थीटा 1 इज एक्चुअली, है ना, अगर ध्यान से देखा जाए, सो दिस, है ना, दिस एंटायर इज 2 थीटा, दिस इज थीटा 1. ओके, सो tan थीटा 1 इज बेसिकली r बाय 2 y. ठीक है, तभी लिख देते हैं हम लोग, है ना. tan थीटा 1 इज r बाय 2y इज इक्वल टू के क्यू स्क्वायर बाय आर स्क्वायर एम जी. ये हो गया पहला इक्वेशन. नाउ फॉर द सेकेंड इक्वेशन वी हैव थीटा 2 हियर नाउ. ओके, तो थीटा 2 के लिए हम लोग करते हैं, है ना. सो फिर से वही हो जाएगा, t cos थीटा 2 इज गोइंग टू बी इक्वल टू एम जी, t sin थीटा 2 इज गोइंग टू बी इक्वल टू k क्यू स्क्वायर बाय r डैश होल स्क्वायर. ओके, सो देयरफॉर tan थीटा 2 इज गोइंग टू बी इक्वल टू k क्यू स्क्वायर divided by r dash square into mg. Now what is tan theta 2 here? It is r dash by 2 divided by y by 2. ठीक है, पहले y था लेकिन अब y by 2 हो जाएगा. tan theta 2 is equal to r dash by 2 divided by y by 2. So basically this is r dash by y. So let us write here r dash by y is equal to kq square by r dash whole square mg. This is the second equation. Okay, so now we can very clearly write, comparing equation 1 and 2, we can write that r cube by 2y is equal to r dash cube by y. So this is gone, this is gone. So therefore r dash becomes r divided by cube root of 2. ठीक है, so this is the D equation, D option. Thank you. Suppose the charge of proton and electron differs slightly, one of them is minus. ठीक है, तो अब देखिए ये क्या बोल रहा है कि between two hydrogen atoms placed at a distance d. तो हाइड्रोजन एटम में होता क्या है, हाइड्रोजन एटम में देयर इज न्यूक्लियस, न्यूक्लियस में एक प्रोटॉन रहता है और बाहर में क्या रहता है, इलेक्ट्रॉन रहता है, ठीक है। अब इलेक्ट्रॉन का चार्ज है -e, प्रोटॉन का चार्ज क्या है, e प्लस डेल्टा ई। तो we can write and we can tell that the net charge on the hydrogen atom, a single hydrogen atom, is E plus delta E minus E, which is delta E. Okay, so although I have shown atom to be quite big, but atom is really very small. So now let us do this. So there is these two hydrogen atoms. Okay, it is having delta E net charge, this is having delta E net charge, the distance between them is d. Okay, so now what the question tells us, the question is telling us that the gravitational force and the electrostatic force both are same. So therefore I can write that G into m mass of hydrogen square divided by r square should be equal to k into q square. What is the net charge, delta E. So delta E whole square divided by r square, gone. Now G is 6.67 into 10 to the power minus 11. Mass of hydrogen is 1.67 into 10 to the power minus 27 into 1.67 into 10 to the power minus 27 should be equal to k. K is 9 into 10 to the power 9 into delta E whole square. Okay, अब क्या कीजिए, like the delta is the order of, okay, so this is 6.67 into 1.67 whole square into 10 to the power it is minus 54 and minus 20, it's minus 74 divided by 9, this is equal to delta E whole square. So therefore if you see, delta E is going to be root of it, so root होगा तो इधर आ जाएगा 10 to the power minus 37 आ जाएगा. So therefore it is of the order of 10 to the power minus 37. Okay, we need not calculate the entire thing. Okay, ठीक है. And this also should be very clear that the net charge on each hydrogen atom, I am writing here, net charge on each hydrogen atom becomes delta E. Thank you. A short electric dipole is a dipole moment of 60 into 10 power minus 9 coulomb meter. Okay, so this is the dipole, fine, minus q and plus q, and at a distance of r, potential is going to be kp cos theta divided by r square. Okay, now we have to do the entire thing. So now v is, so that's what we have to calculate. So k 9 into 10 to the power 9 into p, that is 16 into 10 to the power minus 9 sorry, into cos 60, cos 60 is 1 by 2 divided by r square at a distance 0.6 meter sorry, so therefore 0.6 into 0.6, so this is multiplied by 100 सॉरी, तो 6 से 3 से गया, it's 3, it's 2, so this also becomes 2, 2 is 8, it is 2, it's gone, so this becomes 200 volt. So A is going to be the answer. Thank you.